I've always been fascinated by the sheer scale of the universe, and today we're going to explore something truly massive. We're talking about stars, but not just any stars. We're diving into the realm of the largest stars in the known universe. These celestial giants are so enormous that they challenge our understanding of physics and push the boundaries of what we thought possible in the cosmos. Now, you might be wondering, how do stars even form in the first place? Well, stars are born when massive clouds of gas and dust in space collapse under their own gravity. As this material gets denser and hotter, it eventually ignites nuclear fusion in its core. But not all of these collapsing clouds make it to stardom. Some end up as brown dwarfs, essentially failed stars that never quite got hot enough to sustain hydrogen fusion. But let's focus on the stars that do make it. Our Sun, for instance, is what we call a main sequence star. It's happily fusing hydrogen into helium in its core, and it'll keep doing that for billions of years. But the universe is full of variety. We got tiny red dwarfs, which are actually the most common type of star. And then we've got the big, hot blue giants that burn through their fuel like there's no tomorrow. So what happens when stars get really, really big? Well, that's when things start to get interesting. As stars exhaust the hydrogen in their cores, they begin to expand. The largest of these become what we call supergiants and hypergiants. These stars are in a constant battle between gravity trying to pull them in and radiation pressure pushing outward. Consider this for a moment. A hypergiant star like Rho Cassiopeia is so unstable that its size actually fluctuates. It's almost as if the star is breathing. This is absolutely mind-blowing when you consider the scale we're talking about. These stars are shedding mass at an incredible rate through powerful stellar winds. Now, let's talk about the current contender for the title of largest known star, Stephenson 2-18. This cosmic behemoth is estimated to be about 2,150 times the radius of our Sun. To put that into perspective, if we placed Stephenson 2-18 where our Sun is, its surface would extend beyond the orbit of Saturn. That's right, it would swallow most of our solar system whole. It's pretty hard to wrap your head around, isn't it? But here's the catch. Measuring the exact size of these stars is incredibly challenging. They're so far away, and their boundaries are often fuzzy due to their extensive atmospheres. Plus, they're constantly changing. As we've seen, the universe operates on scales that are hard for us to truly comprehend. From tiny red dwarfs to the mind-boggling expanse of Stephenson 2-18 stars showcase the incredible diversity and sheer magnitude of the cosmos. Next time you look up at the night sky, remember, you're gazing at a vast cosmic laboratory where nature experiments with the very limits of physics. And who knows? Maybe there's an even bigger star out there just waiting to be discovered. Until then, keep looking up and stay curious.